The A320 family is equipped with International Aero Engines IAE V2500 series engines. Like all turbine engines today, this engine has a low-pressure compressor, a high-pressure compressor, and a turbine. The low-pressure compressor, also called N1, consists of a front fan and a low-pressure compressor. Connected to a low-pressure turbine. The high-pressure compressor, also called N2, consists of a high-pressure compressor connected to a high-pressure turbine. The combustion chamber is equipped with two igniters, called A and B. The accessory gearbox is located at the bottom of the fan case and is driven by the high-pressure rotor. Each engine is equipped with a full-authority digital engine control system, FADEC, which provides complete engine management. Each FADEC has two identical and independent channels, A and B. The full-authority digital engine controls are powered by aircraft buses for 5 minutes after power-up, at which time they go to sleep. During engine start, each full-authority digital engine control becomes powered by a dedicated alternator located on the accessory gear case. Therefore, even in the event of total power failure, the pilot still has full control over the engine. Each engine is equipped with reversers. The engines are controlled by thrust levers, which are located on the center pedestal. These two levers control the reversers. The autothrust can be disconnected using the two red buttons, which are called instinctive disconnect push buttons. The controls for engine starting and shutdown are located on the center pedestal, just behind the thrust levers. The engine master switch and the engine mode selector enable the pilots to start the engines automatically or simply dry crank them. Once the engines are running, the mode selector can also provide continuous ignition. Each engine has a fire and fault light. On the overhead, there is an additional panel, which is used in abnormal operation. Engine indications are shown on the engine warning display and on the engine system display page. The primary engine parameters are displayed on the engine warning display. First are the EPR gauges. The green needle and the numerical value indicate the actual EPR. The blue arc is the EPR command arc. It delineates the transient difference between actual EPR and command EPR, TLA or throttle lever angle. It is present only when the auto throttles are connected. The white circle represents the predicted EPR. It will correspond to the thrust lever position, TLA. The amber mark is the max EPR limit. It will correspond to the EPR allowable in the toga detent. EGT is indicated in green by the pointer and numerical value. Both indicators pulse in two colors. Amber when EGT is greater than 610 degrees. Red when EGT is greater than 635 degrees. The amber tick indicates the maximum allowable EGT. 635 degrees Celsius during the start sequence. 610 degrees Celsius after start. Note, the amber tick is not displayed during takeoff. The beginning of the red area is over temp EGT. When 635 degrees Celsius is exceeded, a red line appears at the maximum reached value. The actual N1 is indicated in green by the pointer and numeric value. Both indicators pulse in two colors. Amber when N1 is greater than the N1 rating limit. Red when N1 exceeds 100%. The red line indicates the amount of overspeed. The N2 gauges consist of a white N2 identifier with the actual N2 speed shown numerically in green. Should an overspeed occur, the N2 value will turn red, and a red plus sign will appear next to the number. Even if the overspeed is corrected, the red plus sign will remain until maintenance action is taken. On the right side of the engine warning display, the thrust limit mode and EPR rating limit are displayed. Also, the fuel flow for each engine is displayed. On the engine system page, secondary parameters are displayed. The first indication displayed is fuel used. This value is frozen at engine shutdown and is reset to 0 at engine start. Next are engine oil quantity, pressure, and temperature. These indications are normally green. Oil quantity limits are cold, below 30 degrees Celsius, 10.5 quarts. Hot, above 30 degrees Celsius, 17 quarts, plus 0.6 of a quart per hour estimated flight time. Start valve indications and bleed pressure are displayed during the start sequence when the engine mode selector is in the ignition start position. They are also displayed when the selector is in the crank position. Ignition indications are displayed in green. When using the auto start procedure, only one igniter is used, alternating from A to B with subsequent starts. When using the manual start procedure, both igniters are used. Both igniters are automatically applied when takeoff thrust is applied, engine anti-ice is turned on, airborne when flaps are not up, engine surge, sub-idle, stall. Vibration indications are normally displayed in green. At 1500 feet AGL, the engine ECAM page is replaced by the cruise page on the system display. The cruise page displays the fuel used for each engine, the oil quantity for each engine, and the vibration level for N1 and N2. On the ground, thrust control is entirely conventional. The thrust lever position determines the thrust. The thrust levers can be moved manually over the entire quadrant. They never move automatically. There are 6 detents on the quadrant: idle, climb for maximum climb thrust, flex max continuous thrust, one detent serving 2 functions. Flex is used for reduced thrust at takeoff. MCT, max continuous thrust, is used for single engine operations. Toga for maximum takeoff or go-around thrust. Idle reverse for idle thrust when reverse is selected. Max reverse for maximum reverse thrust. Thrust control can be achieved in 2 ways: manually, using the thrust levers as in a conventional aircraft; automatically when the auto thrust is engaged. On the ground, the thrust limit mode is toga or flex. The selected mode is displayed in the upper right-hand corner of the engine warning display. Toga represents the maximum thrust available from the engine for the actual outside air temperature, OAT, of the day. The EPR rating limit displayed alongside the selected mode indicates the related EPR value. Flex is used for a reduced thrust takeoff. To achieve the thrust reduction, an assumed temperature, or flex, is used. For example, 45 degrees Celsius. The flex temperature is displayed beside the EPR rating limit. This means that the engines will perform as if the takeoff was made at full power with outside air temperature at the flex value. The result is that the actual takeoff thrust is reduced, which helps to prolong engine life. We will demonstrate a flex takeoff, since this is what you will normally do. The first step is to move the levers from idle to approximately 1.05 EPR. Click on the thrust levers to apply the thrust. When 1.05 EPR is reached, flex takeoff thrust is applied on both engines by smoothly moving the thrust levers to the flex detent. Continue to apply takeoff power. When you reach the flex detent, the pilot not flying checks that the indicated EPR is the same as the EPR limit. The full authority digital engine controls will maintain takeoff thrust and monitor for overspeeds and temperatures during the takeoff. Note, toga thrust is always available by moving the thrust levers to the toga detent. At the United Airlines Thrust Reduction Acceleration of 800 feet, AGL, the thrust levers are moved to the CL detent to select Climb Thrust. Select Climb Thrust. During takeoff, the auto throttle system has been in the armed mode only. As soon as the throttles are placed in the Climb detent, auto thrust is automatically engaged. The thrust limit mode turns to Climb and the EPR rating limit changes. At 1,500 feet above ground level, the ECAM engine page is replaced by the ECAM cruise page on the system display. The aircraft is leveling off. Watch the EPR indicators. When the EPR value changes, an EPR command arc is displayed in blue from the current EPR to the new EPR value. This arc is displayed only when auto thrust is engaged. When the new EPR value is reached, the command arc disappears. We'll look at it more closely. During cruise, descent, and approach phases, auto thrust is normally active, so the thrust levers remain in the climb detent. When auto thrust is connected, if both engines should be at idle, descent, an idle indication appears above the EPR gauges. It flashes for 10 seconds and then remains at steady green. Note that there is a difference between ground idle and flight idle, with flight idle being higher. At around 30 feet on landing, the throttles must be placed into the idle detent to disconnect the auto thrust system. There is an audio call-out to advise the pilot. Select the idle position. After touchdown, reverse should be immediately selected to aid the deceleration of the aircraft. Apply the reversers. On the EPR indicators, reverse appears in amber, indicating that the reversers are unstowed and unlocked. When the reversers are fully deployed, the REB, or reverse indication, changes to green. As the aircraft speed approaches 80 knots, the levers should be moved to idle. Return the levers to idle. To provide for sufficient cool down, it is recommended to leave the engines running for at least 3 minutes after landing.